In an electric dipole, when an electric dipole is placed, when an electric dipole is placed in a uniform electric field, in a uniform electric field, making an angle theta with the electric field, making an angle theta with the electric field. It experiences a torque tau. It experiences a torque tau. The minimum work done. The minimum work done in changing the orientation to 2 theta. How much, ma'am? Lohit, how much did you get?
Sir, I didn't check actually.
Oh no, this problem, what is the answer you got to the problem?
Oh, I didn't. I couldn't hear the question, sir. Were you narrating the questions? I couldn't hear.
Okay. The torque acting on a dipole is tau. Tau when it is at an angle theta. The work done to change the angle to 2 theta. What about others who heard it?
Sir, could you explain how to do this one?
What is the torque?
It's something related to theta 1 minus theta 2 or something.
Is it not? That's the torque.
Yes.
What is? Yes, ma'am. Tell me.
Work done is MB into 1 minus cos theta.
MB. There's no MB, this is electric dipole. MB is in magnetic dipole. How much is P? Tau by sine theta. What is work done? Cos theta 1 minus cos theta 2. So this will be tau by sine theta cos theta minus cos 2. Any doubt here?
No, sir. No, sir.
Okay. A charge Q. A charge Q is distributed uniformly on a ring. Of radius capital R. The electric potential at the center of the ring So for the ring, charge is uniformly distributed. It behaves as though the entire charge is concentrated at the center. It behaves like a point charge. It behaves like a point charge. So it will be Q by 4 pi epsilon naught R. Okay. Is that clear? Any doubt there? Simple direct formula.
Yes, sir. No doubt.
Okay. A charge plus Q is placed. A charge plus Q is placed at the points x is equal to d, x is equal to d
Sir, a charge plus Q is placed
at the points, a charge plus Q each is placed at the points, a charge plus Q each is placed at the points, x is equal to d, x is equal to d, x is equal to 3d, x is equal to 3d, x is equal to 5d, and so on. And so on the x-axis. On the x-axis. And a charge minus q. And a charge minus q is placed. It is placed at each of the points. At each of the points. X is equal to 2d. X is equal to 4d. X is equal to 6d, and so on till infinity. Find the electric potential at the origin. Come on, ma. What happened?
Sir, can you give options?
KQ by D. First option. If I give options, the very purpose of dictating the problem is lost, my dear. Because
So,
it will be a guesswork. That's why I don't want to guess. There is nothing more than that. My intention is you should do it.
Okay, sir, don't give me.
Do it. It's all right. If it goes wrong, what is there? The trial part is very important. We
Like
learn
near
by
option.
Yes, ma. Tell me, ma.
Like near option, we can choose na sir, giving option.
Near?
If you give options, you can choose like near options, like plus or minus.
Okay, it's all right. You tell me approximately what is there. Okay. Dr. Kaushik, are you there? Dr. Ravi?
Sir, I think I got the answer.
Okay, tell me, Dr. Rohit, come on.
Minus q by 8 pi epsilon naught.
Okay. Minus q by 8 pi epsilon naught.
Yes, sir.
Okay. Let's see what others got. Other doctors? Other doctors? Dr. Sakina? Lasya? Aishwarya? All should take equal participation. Then only it looks nice. So what did he say? He said that suppose we take this to be the x-axis, then this is the origin. At x is d, 3d, 5d, he is keeping plus q. And x is equal to 2d, 4d, so on, is keeping minus q. So what will be the potential? Q by 4 pi epsilon naught. 1 plus half, 1 minus half, plus 1 by 3, minus 1 by 4, plus and so on, till infinity. So you see, it's not an arithmetic progression, it's not a geometric progression. This is called as a logarithmic series.
Excuse me,
Yes,
sir.
my dear?
Can we take V1 as all the positive ones and then V2 as all the negative ones and then add both of them?
You can't do that. The simple reason is because the net potential is simultaneously due to the potential of all.
No, sir. It's just like it's simultaneous. We're just calculating it differently. Like the first one, V1 is equal
Okay, tell
to
me one. Okay, tell me one.
V1 is equal to Q by
Okay.
4 pi epsilon naught.
Let us check up. Let's check up whether you're let us mathematically check it up. Suppose if I have 1 minus 2 plus 3 minus 4 plus 5 minus 6, so on. Suppose if I 1 minus 2 is minus 1, minus 1 plus 3 is 2, 2 minus 4 is minus 2, plus 3, 3 minus 6 is minus 3. Now suppose we take all the positive numbers. 5 plus 3, 8, plus 1, 9, minus 6, 12, minus 3. This is true because this is in the numerator, but it is not true when I have a fraction.
So,
It is not true when I have a fraction.
I'm just taking that since it's an arithmetic progression, if it's in a fraction, arithmetic progression in a fraction, then I'll get.
This is not an arithmetic progression.
Sir, if we take all the positive integers, it will be a geometric progression, sir.
Okay, even then it is not a geometric progression because we have, suppose we take 1 plus 1 by 3 plus 1 by 5. Is this a geometric progression?
No, the denominator. Oh, wait. No, sir. Oh, okay, yeah.
Is it not here? Right. So is your doubt clarified now? Did you get it?
Yes, sir, it's clarified.
So this is neither an arithmetic series nor a geometric series. This forms what is called as a logarithmic series. So you get 4 by q by 4 pi epsilon naught d log 2 to the base. This is called this is known as logarithmic series. I'm just trying to see whether there are, different types of problems, because I don't want to do the same one what is already there in your material. Charge Q2 of mass m charge Q2 of mass m revolves around a stationary charge Q1. A stationary charge Q1 in a circular orbit. In a circular orbit of radius r, small r. Of radius smaller. The orbital periodic time. The orbital periodic time of Q2 would be I think it's a very easy one. You can do it. What you have to do? Because it is moving in a circular path, the electrostatic force, because balance provides the necessary centripetal force. Because he said it's a circular path. Immediately the force that comes into play is the centripetal force. So the electrostatic force provides the necessary centripetal force. Equate both of them.
Sir, it's root 4 pi square mr cube by k q1 q2.
It is 4 by
root 4 pi square mr square by k q1 q2.
No, dear, I don't think so.
Yes.
Sir, is the answer 4 pi mr cube by k q1 q2?
You people are nearby, but not exact. Because if...
Sir, instead of root power 1 by 2.
To the power?
1 by 2.
Whether you say root or whether you say power 1 by 2, it's the same thing, no dear. See, small mistake you're making. I think when you're saying it wrong. Let me write what you have said. Tell me what you have said. What's the answer you got, dear? Tell me. Yes, Rohit, what did you get?
So 4 pi 4 pi square mr cube.
What did you say before? You said mr square.
by
Okay.
KQ1, KQ2,
KQ1,
KQ2.
again another K.
No, sir, only one K, sorry.
Q1, Q2, okay.
So bracket 1 by 2.
To the power of 1 by 2, you mean to say.
Yeah, sir, to the power 1 by 2. Yes, sir, this one.
The other girl, are you sure about it? Or you got a different one?
Same, sir.
Okay, let's check up. So I said equate the electrostatic force into Q1, Q2 by R square. Okay, you can call this as K is equal to MR omega square. So omega will be Q1, Q2 by 4 pi epsilon naught. Or you can write K Q1, Q2 so, by R cube to the power of half. Does it not? What is omega? 2 pi by T, no? Is equal to K Q1, Q2 by R cube to the power of half. Okay, right. Because you take 2 pi into this, you get the same thing. Got it, everyone? Any doubt there? Any doubt, anyone? Okay, good. A wooden block performs SHM. A wooden block performs SHM on a frictionless surface with a frequency nu naught. Nu naught. The block carries a charge. The block carries a charge plus Q. On its surface. If now a uniform electric field is switched on, as shown. Is switched on as shown. Then the frequency will be this block. This block is attached here to the spring. E is applied Q. The direction of E is the same. Now tell me what happens to the frequency. Will it change? Will it be the same? Will it get doubled? Will it get tripled? What will happen?
Sir, frequency does not depend on external force, no sir. It will be remain same.
Very good, ma. Excellent, excellent, super. Right. It remains the same. But what will change? That part you said is correct.
Sir, force can change the position of the block.
Yeah, so the frequency will not change, but the mean position will change. So the block will be of the same frequency, but with a shifted mean position. Right, it's true. Good. Nice, very nice. Okay. Okay. Two identical charged spheres. Two identical charged spheres suspended from a common point. Suspended from a common point. Suspended from a common point by two massless strings. By two massless strings. By two massless strings of length L. Of length L are initially at a distance d apart. At a distance d apart due to mutual repulsion. Due to mutual repulsion. The charge begins to leak. The charge begins to leak from both the spheres. From both the spheres at a constant rate. At a constant rate. Hence, they approach each other. Hence, they approach each other with a velocity v. They approach each other with a velocity v. If d is very small, if d is very small when compared to x, if d is very small, I'm sorry, when compared to L, not x, when compared to L, then v as a function of x is V as a function of X is yes, Akshaya.
Yes.
Rohit, what happened?
Sir, is it dx by dt? Or,
What I'm asking, V dx by dt is V.
so you asked v as a function of x, no?
Yeah. So that means what is the relation between V and X?
Sir, x cube equals to k v square.
X cube is equal to
K equals to I took the constant k into v.
You mean to say X cube is KV,
kv square.
KV square. That means V is directly proportional to X power 3 by 2.
Yes.
No. Likita, are you getting any other answer, dear?
No, yes, sir, I'm getting.
What is the answer that you got? It is Ravi. So you already did this in your class, but I think you just forgot. So sir must have told you. Of course, I didn't teach you this. So these are two spheres. Is it not? And due to repulsion, they are separated by distance x. If you take this angle as theta, so you know t cos theta provides the weight. T cos theta is balanced by the weight. And T sine theta provides the force of repulsion. What is the force of repulsion? Charges are same. So Q square by 4 pi epsilon naught into x square. So from here again you get tan theta is equal to Q square by 4 pi epsilon naught x square mg. And if theta is very, very small, this is approximately equal to sine theta. You remember you did this two silk threads. Do you remember it? So q square by 4 pi epsilon naught mg into x square. If you bring this side, this is equal to x by L. Na? So from here you get this is x cube. Q square L will become equal to 4 pi epsilon naught mg x cube. Of course, this will be 1. But we can get this side. So from here, what you get? You get q square L by 4 pi epsilon naught mg is equal to x cube. This is x by 2L, no, not L. Because the distance was x by 2. So is equal to 1 by 2. Okay. So this will be x cube by 2. So from here, q is directly proportional to x power 3 by 2. So dq by dt, if we take differentiated, some constant into 3 by 2 into x to the power of 3 by 2 minus 1 is half into dx by dt. So from here, he said dq by dt is a constant. That's what he said in the question. So from here, dx by dt is directly proportional to x power minus half. So v is directly proportional to x power minus half. Okay, Akshaya, is it okay?
Yes, sir.
Any doubt, anyone?
No, sir. You also can ask me any problem that you have, not necessarily that you should. Okay. A block of mass m a block of mass m
having a charge Q, having a charge Q is attached to a spring of spring constant K. Of spring constant K. This arrangement is placed in a uniform electric field E. In a uniform electric field E on a smooth horizontal surface. On a smooth horizontal surface. Initially, the spring is unstretched. Initially, the spring is unstretched. Find the extension of the spring. Find the extension of the spring in equilibrium position. In equilibrium position and maximum extension of the spring. So very simple problem. Do it and tell me, come on.